Hey Ramblers, this video covers chapter 10.6 in our textbook and deals with 4 really helpful theorems, but they're really hard to see. I mean, we can be given all the information we need to use these theorems, but we might not recognize that we have it, because sometimes it can just be presented in a diagram and they're so clear to use, but if you don't see it, then you're not going to be able to use the theorems. So please pay careful attention in the video and in the exercises to make sure that you're recognizing the visual clues that you need to apply these theorems. Okay, the first two are going to deal with congruent inscribed angles and congruent tangent chord angles. So they're going to answer the question, what happens if two inscribed angles intercept the same arc, or intercept congruent arcs? And the same thing with two tangent chord angles. Suppose that they intercept the same arc or congruent arcs. What does that mean for the measure of the angles? Okay, and then the second two theorems are also really helpful. One of them talks about an angle that's been inscribed in a semicircle. And the last theorem that we'll deal with today tells us that the measure of a tangent-tangent angle and its minor arc are supplementary. That's kind of interesting, and you'll find that it's really helpful in solving some of the problems. So please take good notes, pause the video often, and I hope this helps. Thanks for watching. Okay, the first two theorems, 89 and 90, they deal with congruent inscribed angles and congruent tangent chord angles. And let's look at what the theorem says. It tells us that if two inscribed or tangent chord angles intercept the same arc, then they are congruent. Well, let's talk about that. Suppose we see, or we know, that angle X intercepts arc AB. And we also know that angle Y intercepts arc AB. What do you think that implies for the measure of angle X and angle Y? Well, according to the theorem, they'd be congruent. Now let's take a look at the angle measurements involved. We can see that, sure enough, the measure of angle AXB is 53.69 degrees, and the measure of angle AYB is 53.69 degrees. No matter how I manipulate the diagram, you can see that since they're intercepting the same arc, that the angles AXB and AYB will be congruent. Okay, let's move then over to a tangent chord angle. Well, here we have angle LJM, we know is going to measure half of arc LJ. And angle LKJ is going to also be inscribed in the same arc LJ. So, since both the tangent chord angle and the inscribed angle are half the measure of this arc, the angles should be the same. Let's take a look at what the geometry sketchpad measured for us. And sure enough, LJM is 53.41 degrees, and LKJ is also 53.41 degrees. I'm not going to prove these for you because it's rather self-evident that if two angles are intercepting the same arc and they're both half the measure of that arc, that they're congruent. Okay, let's take a look at the other two theorems for this video. Okay, Theorem 90 is very similar to Theorem 89, but instead of two angles intercepting the same arc, here two inscribed or tangent chord angles are intercepting congruent arcs. And let's look at how that affects their measure. So angle VTU is going to intercept arc VU, and WXY are going to intercept arc WY. Well, as you can see, those two arcs are congruent. So it's not surprising that the angles that are intercepting them are going to be congruent because they're both half of the same measure. All right then, let's take a look at the other diagram where we have two tangent chord angles that are also intercepting congruent arcs. Arc AW is 74 degrees and arc ZB is 74 degrees. No surprise then that the angle intercepting arc AW is congruent to the angle intercepting arc ZB. they're both 37 degrees, which is half of the two congruent arcs. Okay, let's make sure that you have these two theorems in your notes, and then we'll move on to the last two theorems for this video. Okay, Theorem 91 and 92 are really helpful also. Theorem 91 describes an inscribed angle in a semicircle. So angle C here is inscribed in semicircle BCA, and its measure is 90 degrees, or a right angle. You could also think of it as inscribed angle BCA intercepting arc AB, which is a semicircle. Either way, no matter where we place this inscribed angle, which intercepts a semicircle, the measure of angle C is 90. Even if we kind of move the diameter around, it's still equaling 90 degrees. Now, what makes this difficult to see is because this diameter isn't always there. And you'll notice that when that's hidden, it may be a little bit harder to recognize that angle C is a right angle, but nevertheless it is. So keep this in your notes and really try to make sure that you're recognizing it when it comes up. Okay, let's take a look at Theorem 92. Now, Theorem 92 tells us that the sum of the measures of a tangent-tangent angle, like angle P, and its minor arc, which is there, is 180. So let's see if we can't. So in other words, the measure of angle P and arc TS is 180. They're supplementary. And sure enough, when I show that, I can see that arc TS is 126, angle TPS is 53.68, but regardless, their sum is always 180. No matter how I manipulate this, the angle can change and the length of the arc can change, but the two are always supplementary. All right, let's take a look at the proof of why that's true. When you look at the sum of the angles of this quadrilateral, PSOT, they would of course add up to 360. We learned that in Chapter 7. We know that from this chapter, angle PTO and angle PSO are 90 because OT is a radius and OS is a radius. Therefore, when they meet these tangents, it's 90 degrees. So if I subtract PTO and PSO from our equation in step 1, I see that angle P plus angle O is 180. Well, we also know that the measure of arc TS, is equal to the measure of central angle O. So I can substitute arc TS for angle O in our step 3 to give me my conclusion that angle P plus arc TS equals 180. Okay, the proof's not that important, but certainly the conclusion is. Make sure you know that the sum of the measures of a tangent-tangent angle and its minor arc is 180. Better said, tangent-tangent angle and its minor arc are supplementary. Okay, thanks for watching, Ramblers. Number 23 on page 484 gives problems every year, so let's take a look at it. It tells us that AB is the diameter of circle P, and what is more, they tell us that AB is 13 units. We also know that QR is 6, and that AB is perpendicular to QR. Well, since I recall from the video that an angle inscribed in a semicircle is 90 degrees, angle AQB must be 90 degrees. And this is starting to look like a pretty familiar diagram that we've had this semester. QR must be an altitude drawn to a hypotenuse, AB. So that's another thing to keep in mind. Whenever an angle is inscribed in a semicircle, that means that the diameter is the hypotenuse of a right triangle. So, how can I find RB, which is x? Well, I'm going to use the altitude of the hypotenuse theorem. And RB will be x, and so AR is 13 minus x. So, if I multiply 13 minus x times x, I will get the altitude squared, which will be 36. Okay, if I set up the quadratic and solve for x, I can see that x equals 9 or 4. But do both those answers make sense? We can eliminate 9, because if AB equals 13, then the radius must equal 6.5. And clearly, RB, or x, is less than the radius. So, RB equals 4. Let's take a look at another problem in this section on problem number 24. Also gives trouble from year to year. Okay, number 24 on page 44 causes trouble every year too. So let's take a look at it. It tells us that RH and RM are tangent to the circle, and they want us to find the length of arc, or I'm sorry, the measure of arc HM. Now there are three important facts to consider. First, I know that angle O, since it's an inscribed angle, is 1/2 of arc HM. And from this video today, I know that angle R plus arc HM is equal to 180. And finally, I know that angle R and angle O are congruent because they're opposite angles of a rhombus. So substituting that angle R is 1/2 of angle O, I'm going to substitute from this first diagram, or I'm sorry, the first equation over to here, and I'll see that angle R equals 1/2 arc HM. I'm going to now substitute that expression in for angle R in the middle equation. So I have 1/2 arc HM plus arc HM equaling 180. So 3/2 arc HM equals 180. So solving for that, I can see that arc HM equals 120 degrees. And that's the answer as given in the teacher's edition. Alright, I hope this helps, Ramblers. Thanks for watching.